Okay, so let's imagine you have a shotgun, right? And that shotgun has a bunch of URLs. And so your initial URL is going to be your initial shot. And so from that shotgun, you shoot out, let's say three shots here. So we have 1, 2, I'll put that here, and then 3. From those 3 shots, more shotguns are generated, right? So we have 3 more shotguns. And then those can also shoot out 3. So 1, 2, 3, 1, 2, 3, 1, 2, 3. Now it's getting a little bit too large for Microsoft Paint. And so what are these going to do? Well, each of these guys, like I said, so you have initial URL and it shoots out, three URLs, right? And so from each of those URLs, they shoot out 3 more. So what does that mean? What do I mean by this? This is just how I like to visualize it. So this is your seed URL, right? Your seed. So you start with this URL. And then from that URL, I call it a shotgun because it's a random spread. So you get you get 3 random URLs. In this case, 3 is going to be our cap number, rather. So here's our cap. So in the program, you'll see a word called cap, or a variable called cap, a word. And so that's going to be the amount of pellets, I guess, in your shotgun. So it's the amount of URLs you're going to find. And so the amount of times you're going to be doing this is your iteration count. So iter is going to be 3 in this case as well. And the reason why that is there's 3 layers, right? So 1, 2, 3. 3 layers to this. So you have your initial seed URL. You're going to shoot out 3 pellets randomly, a random spread. And each of those pellets is going to turn into another shotgun, which can shoot out another 3 pellets, which can turn into another shotgun. And then once it hits the round of iterations, once it reaches the 3rd layer, they all stop and they all bring the URLs back to your initial URL. So let's see what this actually means. Basically, this is a way to get a random spread of URLs, and then you can parse the language that's in each of the web pages. Alright, so let's look at the code here real quick. I'm going to have a linked, in the description, it's going to tell you, okay, if you just want to see how it works and just see the CSV at the end, you can just go to this timestamp. But anyway, so we have, of course, just the main. This is just regular. I have a bunch of throw IO exceptions just because I don't feel like actually dealing with the exceptions, so there's no catching. So we have our initial URL, which is our seed URL. So we'll look into that a little bit in a second. So now we have a brancher, and we're going to initialize the brancher, and then we're going to create a scrape of it. I don't have the CSV here yet because I don't want to do anything with it yet. I just want to show you kind of how this works. And then we're just going to print all the URLs, but I don't have to have that there. So let's look into the brancher. So the whole idea of this is that you have an initial URL, right? And then it branches out into a bunch of random URLs through a bunch of iterations, I think it's called like a tree. I've seen like binary trees or something. And so what the whole point of that is to have a bunch of random, just from one seed URL, have a bunch of, connected in some way URLs. And so you can do a bunch of stuff with this. The thing that I'm going to be doing with it is I'm going to be implementing a Japanese URL. And so from that, I want to scrape all the words from each of the URLs that I find. So, okay, this is just a bunch of random imports. I actually don't need this one. I'll clean this up before I put it into the GitHub. We have JSoup. JSoup's kind of like Beautiful Soup for Java. Here's just your regular expressions. So branchers. So again, branchers is going to branch out to the cap number of random URLs. So if cap is 3, that means that from the first URL, you're going to find 3 more. From the second one, you're going to find 3 more. If it was 4, you're going to do 4 more. So just some information. You have the initial URL. You have to make a document. From this document, we're going to find the URL. So we'll get into that in a second. Iterations cap. This could probably just be a static variable because this isn't going to change once I set it, but that's okay. Just the way how I'm going to calculate it. So if you have, let me pull up Paint. I just want you guys to get an intuition of how I'm doing this. So obviously for the first URL, you're going to create 1 document. Now for this second, or rather for the second layer, so here's your first layer, n is equal to 1, I guess. Your second layer, you're going to create 3 more documents, so you still have 1s in there. So now n is equal to 2. And so for this, the 3rd layer, you're going to create 3 out of each of these 3. So 1, 1, 1, 1, 1, 1, 1, 1, 1. So n is equal to 3. So what's the pattern here? Well, in each layer, you're going to have cap to the n minus 1 like total documents, right? So whenever document number is 1 and cap is 3, you're going to have 3 to the 0, which is 1. Whenever you're in layer 2, you're going to have 3 to the 1, which is just 3, and then that total. So you sum these up, and then you're going to get, this is 9, this is 3, that makes 12, this is 13. So when I do this, and I print out the max iterations, you should see 13. All right, so master URLs is just a giant array list. Keep in mind whenever I'm doing this, I came from Python. So lists in Python are very versatile. Array lists in Java seem to be very similar, so I've just been kind of abusing those. So we just have a bunch of URLs. That's where we're going to store every single URL that we actually get. So each of those, whenever I had the little paint drawing up, each of those little ones, the documents, the URLs from those documents is going to be put in this array list. So master titles is just the titles from each of those URLs. Working URLs is a updating list of the URLs that I'm using for the branch links. So branch links is what I'm actually creating from the single brancher. We'll get to that in a second. Finished URLs is what I'm removing from the working URLs. So once the URLs are finished, we're going to remove it from the working URLs. Branch count just helps me count what branch I'm on. So we start at 1 because brancher is technically the first branch. And so what I'm going to do is I'm going to iterate until I reach the max iterations. And so it's going to stop once I do that. So this just helps me count the amount of branches I'm at. So pattern is just the URL pattern, which is because I'm using this initial URL. This is from Hero's Japanese web Wikipedia. I could just open it up. Hiroyuki Nishimura, or Nishimura Hiroyuki, I guess when you put it in that way, his page. So this is our seed URL, and since I only want stuff from Japanese Wikipedia, I just have this kind of root, I guess I could call it as well, of URLs that we're only going to have URLs from Japanese Wikipedia, because if you don't, the way that HTML is kind of set up, I guess, is that if you look at like the page source, there's a bunch of crazy links to stuff that's not really relevant, I guess, to what you want. So whenever you're actually working with this, you can just change it. The only thing that you have to change is just this part. This plus just means that you have one or more, and then this returns that whole statement. So only change this part. The dot plus, rather, I should say, stays the same. This part here, everything from http to org, you can change to whatever root you want. URLs just contains the URLs. This is only the initial URLs from this guy. So we start with this website, right? And so there's tons of URLs. And so this is the initial list of those. Everything else gets put into the working URLs. All right, so then we have first run is true. That's just to print out some of the stuff whenever we're doing this the first run. So just to print out, okay, well, max iterations. Maybe I should put an equal sign here just to make that easier to realize. All right, and now we're going to actually create the brancher. This is a constructor, so we have the initial URL. We're going to put in the iteration amount and the cap amount. Just going to throw exceptions, not even catch them. Okay, so we create the initial URL here. We append to master URLs, and then we add this initial URL to URLs. Then we create the document, so we can store it and make the branch links. So the document, the only reason why I need that is to actually find URLs from that document. So we'll look into that in a second. Then master URLs, we add this master titles, we add this title just so that we can print off all the titles that we got before, or once we're done. Iterations, this is just setting some variables. And then this is just, if we're at the first run, we're setting max iterations to basically sigma of what I just kind of showed before with the whole n-1. In this case, because I'm setting I to 0, n-1 doesn't really have to occur. It's just da to the I, so cap to the I think. And then set first one to false, and then just do that. Okay. So now we're going to initialize the brancher. That'll call get URLs and then start branch. So get URLs is a method that takes in this .urls in this initial document. So this is only going to be called once. In fact, I probably could, in the GitHub, I'll probably fix this. This URLs, I think I could just put it in the first run because we're only using it once, but whatever, I'll fix it later. It works right now. All right, so we put the URLs and the documents in here. The URLs is a list of a bunch of URLs. So what we're doing basically is we're looking through all the links, right? The href or whatever. in the URL, and then we're looking through all them. We're getting the absolute link, and then we're applying the matching pattern on here, which is, if you recall, the pattern is whatever has the root of this guy. And then we're just saying, okay, well, if it matches and if it doesn't already contain the URL, then we're going to add it. So one of the issues with this, right, and I don't know how to fix this yet, is that let's say we have this URL, right, Hiroyuki. That was weird to pronounce that in English and not Japanese, but Hiro, whatever. Within the same URL, oftentimes Wikipedia, if I were to click this one, right, this word, Raiseki, or sorry, Raireki, if I were to click this, it's technically a different URL because it changes this part, but it has all the same contents. So it's like, you know, technically this is the same URL, everything in Mokuji, which is like kind of like the table of contents. This is the same URL, or sorry, the same contents, but it's a different URL. As you can see, if I were to pop off this guy, it's the same thing. So that's an issue. I don't really know how to fix that. But this is kind of the naive approach, that is just to ensure that at least the URL itself is not the same, even though the contents might be. But typically, you're pretty much fine because you have a ton of URLs to pick from. Okay, and then now we're just basically going to thin the URLs. So thinning URLs is when you call this thinning method, what it does is it basically, while the URL list that you're putting in, which in this case was the this.urls, while that list is greater than this.cap, so while it's greater than 3 in our example case, then we're just going to keep on removing random URLs until we return a list that's only the size of 3. All right, and then just start branch. When you start the branch, basically we're just going to start the initial branch, which is from the initial URL. So in this case, you know, Hero's initial URL. Okay, and then we're just going to create seed URLs, and then we're going to create branch links from those guys. And then while branch count is less than max iterations, we're going to be creating branch links. All right, so let's look at the branch link subclass. So it's inheriting some of the things from Brancher. So it does a lot of the same things. Basically has initial document, has initial URL that it's passed in, has a string of URLs here. What it does is each time you make one, the branch count increases so that we can iterate over it. And then right now I just have this thing. I'm going to comment this out. This is going to be easiest if I just show you. So just look at the GitHub for the rest of this. So right now I'm just going to be, from this URL, we're going to spawn a bunch of URLs, and I'll kind of see where they go, I guess. So, okay. So we start with the first URL, which is this guy, right? And so from there, we branch off, and remember, this is just printing the iteration amount. So there's only going to be 12 total branchlings, or rather 13. We're starting at 0 because of the way that computer science works. Okay, so let's open up this guy. All right, so this says, you know, some Waseda University. And so if you look at this URL, it has it in here, okay? So that's the first branchling. That's going to be the one that spawns that. So within this branchling URL, we should find stuff from Waseda University. Now, sometimes it's hard to find exactly. This is probably like the history of how it was made or something on the URL, because it's not like the same title. It has a different link. So I'm not really going to be extensively checking this. Yeah, this is definitely from Waseda, so you can find it here. And then there's going to be another one. So let's look at the second branchling. And okay, this is the same thing, right? So it's the same contents, but technically a different URL. So from this branchling, you're going to find, you know, some of these stuff. So Inze, and I think this is probably somewhere in here. Yeah, so it's within, basically what I'm trying to show you is that within each of these URLs, we're finding these URLs. So let's look at this third one. And again, I guess it does the same thing. So that kind of is an issue, where again, these are technically different URLs, but we know that they're the same contents. And let's just look at branchling 5. So now from branchling, I believe it was 2. Remember whenever we looked at Waseda, we're making another branch link off of that branch link. So this is from campus, so Waseda campus. And so now everything from this branch link, which I think was it 5 is what I just did? I don't remember exactly. Yeah, it's this one. Everything from this branch link is going to be searching through this guy. So I'm not sure if I can find this. Okay, so here's the link. All right, and then we can continue until the last URL. So let's just see what this is. Okay, so we have this guy. And so again, if I look through this URL, we're going to find this link somewhere. So maybe, hopefully it's not just some ugly link. Let's see if I can find it here real quick. It's probably in here somewhere. Maybe it doesn't have the same title. It might be within the source code of the page somewhere. I'm not going to worry about it right now. So let's see this actually in action with the CSV. So the main, I guess, crux of this program was getting all the random URLs. But once you do that, what I really wanted to do with it was to help find just some language, within this URL. So meaning like, what are the most common words within this, random batch of URLs. So that's where I use this class called master scraper, which I mean, just got to be careful saying that. And so it basically is just going to be scraping each of those URLs and then finding the most common language in each of those. So let's start with this page and let's create one. So actually I will show the titles and the URLs just so, because we can understand how we're actually creating the scrape. Okay, so let's actually create the CSV. Let's put this over here. Hopefully we're not going to run into that kind of bug, I guess, where it just kind of screws up the URLs. Okay. So let's see what we get. So it says, okay, CSV file created. So we have the first title that we get, which is just, again, heroes page. Then we have 2channel from that. Then from that we have bus jaku jiken. So I think it's in here somewhere. Yeah. So within this page we have that. So again, the first 3 branch links are going to be coming directly from this. Or at least I think they are. And so the rest of them will keep on going. So then we have basically like insurance, life insurance. This is the year 2014. This is like business. This is the bus jacking again, but a different link. This is Osaka, like police. Here's like the help page. Here's Edo Jidai, which is like the Edo period in Japan, so I don't know where that came from. This is Wikipedia Niaru Zahyo, which is, I don't know what that would look like. I guess that's like the, just like an index, kind of? Not sure. Then we have Inyo, which is like, almost like I guess reference would be kind of like the word. All right, so what we're going to have is we're going to have duplicates for this one, which is too bad. We can do another one in a second, but basically I want to show you what the CSV file does. So it's going to find you the most common language. So again, you're going to be dominated by particles. We have getsu, or well, I guess that's the character, but it's probably gatsu, which is like the month. Henshu, which is like editing. So I'm sure that just because this is part of Wikipedia, editing is going to be in there. Toshokan is like a library. Keisatsu is like police. So I guess that's from that police article. Jiken is probably from the bus article. Category is probably just from Wikipedia. Osaka. Edo is probably from that one Edo article or whatever. Keijiban's like the type of... Okay, so Hiro made this site called 2channel, and it's like a Keijiban sort of website, which is like a online board website, almost like Reddit, kind of, I guess. Bunch of words that, I kind of know already, like kanji. This is... I'm familiar with this word. I guess I could just look it up if you guys wanted to see. Oh, it's going to pick up the Chinese version, so let's just do this. Okay, yeah, footnote. Let's go towards the end, because that's probably the most interesting language. Is like, okay, what's like the least common? That's interesting. Ni now is not too common, I guess, in here. This is like a like a name. Let's see, anything immediately. Tozan is like bankruptcy. This is like, I think this is like a type of food. No. No. Oh, well, wild boar, I guess, okay. I have seen this character in food. Yeah, okay, I have seen this character in food. So that's interesting. Anyway. Let's do one more. Just go all the way to the end and see what the last result is, which is not necessarily the least common, right? All these are ones, so... planning, so just planning. That's boring. Let's find this guy, maybe. That's just a name. Okay, let's do one more. Maybe do two more, because it is interesting just to see, you know, what URLs have links to which ones. And now we're going to print all the URLs. Okay, so we start with hero, and then we go to this. I don't really know what this is. Let's see. Fusosha Shinsho, which I guess this is some sort of paper, maybe? Not too sure. It's from Osaka. Okay, so then we also have Shoseki Jouhougen, I believe, is how you'd say that. Somewhere in here. It's somewhere within this link. So, you know, you're hearing all these little beeping noises because it doesn't directly find it. Then we have Twitter, which is probably directly from Hiroyuki's thing. Then we have February 28th. Then we have, again, unfortunately, we have a duplicate of that guy. Then we have creating account on Wikipedia. Then we have Ryosha Kaiwa. So I guess this is like a meeting of like the users. Toko Kiroku. So I guess this is like the history of a post on this. I don't know what this is. Let's go to that. Okay, so this is just kind of like a dummy. Then we also have Twitter, but we have Daitoryou Senkyo e no. I just learned this word. I forget exactly what it means or how to pronounce it. Kansho. So interference, kind of. Yeah, that's what it is. Interference. So this is talking about whenever Twitter shut down Trump's account. So that's interesting how that came all the way from Hero's site. Then we have basically, what's the 5th month? Is that March or not March? Is that May or something? The 23rd of that. Mumenkyo unten, so driving without a license. That's interesting. Yeah, I believe that's what that is. Okay, so let's look at the most common words real quick. So again, particles, toshi or nen is like the year, getsu or gatsu is like month, nichi I guess is a way of reading that, that's like day. So that's probably all from the month sort of thing. So this guy, a lot of the times in Wikipedia you're gonna have like, okay, yeah, when was this created, stuff like that. Toko, which is, I mean, you can look this up I guess if you wanted to. It's like a post, so probably from all the Twitter stuff. Etsuran is like viewing, so like if you're on like a website, like inspection I guess is what it calls it. Hyoji is like displaying. Kensaku is like to look up. Jouhou is information. Unten menkyo, so this is probably just from that, driving without a license, if that's what that means. I'm pretty sure that's what it means. This is a word that Tolketsu, that should be like freezing, right? Yeah, probably freezing the account on Twitter is where I'm going to imagine that. Eigo is English. Kino is like not feature, like you're able, like ability kind of an app function. Yeah, I couldn't figure out the English word. Okay, let's look at some of the least common ones. This is, yes, Yuseki. Moto, that's interesting that there's only one there. It's a decently common word. Ansatsu is like assassination, so I wonder where that comes from. Kaikyu is like rank, kinda. Social class, yeah. Dorobo is like burglar. Meiyu is like alliance? Sworn friend. No, sorry. Dolmei is alliance, I think, and then sworn friend is that. So, I mean, you can play around with this and you can see what words are just really, not very often used. Let's do one more, just for fun. So we start with, again, with hero. Okay, we get a duplicate. That's too bad. I don't know what together means. I don't know what that is. Twitter something. Okay. Then from there we get, let's just look at this. It's some language, I guess. Kusatsu. Kusatsu go. I'm not sure what that. パソコン通信やインターネットの電子掲示板において文字を Oh, this is probably like I'd imagine like using like LOL and stuff like that. Oh, no. Is this ASCII art? I don't know. I'll have to look more into that. So that's something that I don't know anything about. Kinoko no Yama. Okay. So Hiro had this thing. There are these two candies. One of them's Kinoko no Yama, and then the other one's, I forget what it is. But that might be within this page. That would be funny if it is. It's somewhere in here. Then we have this, not really sure what that is. Some event. Then we have Dansei, so male YouTubers. Then we have Together again, unfortunately. Then we have the year 2010. Then we have files. This is Kanto Hogen, so like the Kanto dialect. I'm not sure exactly what this is. Not sure what that means. And then we have, again, the history post. Okay, so let's just look at some of the common words. So again, we get month, we get year, we get day, we get editing. Hogen is like dialect. Let's go to the end real quick, see what's up. This is a word that I don't think I know. Okay, and then... no, I have heard of that before. I just haven't heard or seen the kanji, I guess. This is a place, probably? Not sure what that is. Islands, Tolsho. I've never seen that version of islands. You usually see like Shima or something, or like Shoto, I think is also, yeah, archipelago. I don't know how to say that in English. Okay, so that's basically it. I think this is an interesting way to just pick up a bunch of words real quick. All you do, again, you just pop in a URL. Make sure you check the root of that URL, what you want. And then, just get a CSV of all the most frequent words. So that's basically it.